Hello and welcome to this video. I want us to learn how to find the inverse of a complex number. So let's say we have a complex number. Z1 is 2. Okay. So remember we said that if you find a complex number in this form, it means that the imaginary part of this complex number is 0. So we can just write it as 0i. Okay, so that's what it means. So let's say we have a complex number 2. What is the inverse of this complex number? So the inverse means 1 over z1. Okay, so it's going to be 1 over 2, which is equal to 0.5. So that is the inverse of that complex number. So let's have another complex number. Z2 is 3i, sorry, not 3i, but 3 plus 4i. So let's find the inverse of this complex number. So the inverse 1 over Z2 is going to be 1 over 3 plus 4i. Okay, but then we can't leave the answer with an imaginary number on the denominator. So we have to get rid of this imaginary number on the denominator. And the way to do this is to rationalize this complex number, or to multiply both the numerator and the denominator by the conjugate of this complex number. So what do I mean by the conjugate of this complex number? So if we have a complex number 3, let's just use this one, 3 plus 4i, the conjugate of this complex number that we can denote it as z bar is 3 minus 4i. You just change the sign of the imaginary part. Okay, so if we have 2 minus 3i, the conjugate is 2 plus 3i. So for this case, so let me use a different color. So we are going to multiply both the numerator and the denominator by the conjugate. So we have 1 over 3 plus 4i, so we multiply by 3 minus 4i, and also on the denominator by 3 minus 4i. Okay, so on the numerator we're going to have 3 minus 4i, and then on the denominator we have 3 plus 4i times 3 minus 4i. So in the previous video we learned how to multiply complex numbers. Okay, let's work out this, but I will also show you a simple way of multiplying a number by its conjugate. So we have 3 plus 4i, we multiply by 3 minus 4i. So it's 3 multiplied by 3 minus 4i, and then plus 4i, we multiply by, we multiply by 3 minus 4i. So when we work out this, we'll get 9 minus 12i plus 12i, and then we said I times I, or I squared, is equal to negative 1, and then 4 times negative 4. 4 times negative 4 is negative 16. So when we multiply negative 1 by negative 16, it will be positive 16. So we just have, so plus 12i and minus 12i will cancel out, and we are going to remain with 9 plus 16, which will be 25. So this means that to get the conjugate of, or not the conjugate, but to multiply a number by its conjugate. For example, for this case, 3 plus 4i times 3 minus 4i, we could have decided not to work out all these, but then we just, okay, if we have a complex number a plus bi, we can, okay, and we are multiplying it by its conjugate, which is a minus bi, the value will just be a squared and then plus b squared. Okay, so we have a squared for this case was 9, that is 3 squared, and then plus b squared, which is b is negative 4, so negative 4 squared is 16, which is the same as 4 squared, so that will be 25. So when we multiply 3 plus 4i by its conjugate, we're going to get 25, and that is going to be the inverse of this complex number. So whenever we have an imaginary number on the denominator, we don't leave it that way. We have to rationalize the denominator so that we can eliminate that imaginary number on the denominator. Let's have another example. Let's say we have a complex number. Z3 is negative 6, or rather, let's have, okay, negative 6 plus 2i. Negative 6 plus 2i. So I want us to find the inverse of this complex number. So the inverse is going to be 1 over negative 6 plus 2i. But then, as we said, we don't leave the denominator with an imaginary number. So we are going to rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of this complex number. So the conjugate, as we said, will be negative 6 minus 2i. So we just change the sign of the imaginary number. You leave alone the real number. You don't change the sign of the real number. You just change the one of the imaginary number. So let's multiply by negative 6 minus 2i, and then still on the numerator we multiply by negative 6 minus 2i. So on the numerator we're going to have negative 6 minus 2i, and then on the denominator we have negative 6 plus 2i times negative 6 minus 2i. So as we said, you don't have to multiply this through the long method. You can just decide to have a squared plus b squared. Okay, so a squared, so a is negative 6, we square it and then we add it to b squared. B is 2, and then we square it, so this will be 36 plus 4, which is going to be 40. So our denominator is going to be 40. We can confirm whether that is true by using the long method of expanding this one. We have negative 6 plus 2i, or rather, let me just write it this way. Negative 6 we multiply by negative 6 minus 2i, and then plus 2i we multiply by negative 6 minus 2i. So when we multiply this, we're going to have negative 6 times negative 6 is 36, and then negative 6 times negative 2i is going to be plus 12i, and then 2i times negative 6 will be negative 2i, and then 2i times 2i, as we said, I squared is equal to negative 1. So for this case we have I times I is negative 1, and then 2 times negative 2 is negative 4. Okay, 2 times negative 2 is negative 4. So negative 1 times negative 4 is equal to 4. So we can replace this with 4. So that will cancel out with that one, and we'll be left with 36 plus 4, which is equal to 40. So as you can see, you don't have to work out all this. You just have to use this very simple formula here, a squared plus b squared, when multiplying a complex number by its conjugate. So let's meet in the next video as we look at more examples.